So if you've spent any time working with AI, you've definitely heard about prompt engineering, right? It's the art of finding just the right words to get the perfect result. But what happens when the task gets really complex or the conversation goes on for hours? Well, that's where we move beyond simple prompts and into this really fascinating new field, context engineering. It's all about teaching an AI how to focus. So here's what we're going to cover today. We'll start with the AI's attention span, which is a surprisingly familiar problem. Then we'll see why we have to go beyond just prompting. We'll break down the anatomy of what good context even looks like, how AIs can learn to think on the fly, and finally, we'll get into the really cool techniques that let them run an absolute marathon on long, complicated tasks.
All right, first up, let's understand the core problem we're trying to solve here. And you know what? It turns out it's a problem that we humans deal with every single day.
I mean, really think about it. When you're deep into a big project, how do you keep track of everything? There's no way you can hold every single detail in your head at once. You take notes, right? You use bookmarks, you focus on one little piece of the puzzle at a time. Basically, you have a limited budget for your attention.
And it turns out large language models, LLMs, are kind of the same. They have this thing called a context window, which is basically their working memory. And just like ours, it is a finite resource. They have an attention budget, and when you try to cram way too much information into it, things start to get, well, a little fuzzy. And this leads to a phenomenon that engineers call context rot. See, as that conversation gets longer and the context window fills up, the model's ability to remember specific details from way back at the beginning starts to fade. Now, this isn't a bug. It's a fundamental constraint of how these things are built. Every new piece of information puts a tax on that attention budget. So how in the world do we solve for context rot and this limited attention budget? Well, this is where we level up from just prompt engineering to something way more dynamic. Think of it like this. Prompt engineering is about crafting that one perfect instruction for a single, specific task. But context engineering, that's the long game. It's the art and science of curating the perfect set of information for the AI at every single step of a long, complex journey. It's really about managing the AI's memory over time. And this idea is captured perfectly in the source material, which says context engineering is iterative, and the curation happens each time we decide what to pass to the model. It's not a set it and forget it kind of deal. Nope. With every single turn in the conversation, you have to decide, okay, what's critical right now? What's just noise? It's this constant process of sharpening the AI's focus. Okay, so if we're constantly curating all this context, what are we actually managing? Let's pop the hood and look at the anatomy of what makes up good, clean context for an AI. It really boils down to these four things. You've got your system prompts, those are the AI's core instructions. You've got tools, which are basically functions it can use to do things in the real world. You provide examples to show it what a good output looks like. And of course, there's the message history, the running log of the conversation. Context engineering is just the art of balancing all of these. And even just within those system prompts, it's a really delicate balance. If you're too specific, you create this brittle, hard-coded if-then logic that just shatters the second something unexpected happens. But if you're too vague, the AI just gets confused and has no idea what to do. The goal is to find that Goldilocks zone, guidance that's specific enough to be helpful, but flexible enough to let the model actually think.
Now, this is where things get really, really clever. Instead of trying to stuff everything the AI might ever need into its memory up front, what if we just taught it how to find information for itself right at the moment it needs it? This is a technique called just-in-time retrieval. And it's super intuitive. I mean, you don't memorize the entire internet before you write a research paper, right? No, you use a search engine to look up specific facts as you need them. This approach gives AI agents that exact same ability, letting them use tools to pull in data from a file or a database precisely when it's relevant. And the benefits here are just huge. For one, it's much closer to how we humans actually work. Second, it allows for something called progressive disclosure, where the AI discovers new information as it goes, building its understanding piece by piece. And most importantly, it dramatically reduces context rot by keeping that working memory from getting all cluttered. It stays clean and focused only on the job at hand.
So what about the biggest challenge of all? I'm talking about tasks that take hours, or maybe even days. Tasks that generate way more information than could ever fit in a single context window. How do we help an AI run a marathon without completely losing track of the finish line?
To solve this massive problem, engineers have developed what you could honestly call cognitive superpowers for AIs. Let's break down 3 of the most powerful ones: compaction, structured note-taking, and sub-agent architectures. So the first technique is compaction. Just imagine the conversation is about to hit that context limit. With compaction, the AI is programmed to pause, summarize the most critical details of everything that's happened, key decisions, unsolved problems, and then it starts a brand new, fresh context window with just that powerful summary. It's basically creating a previously on recap for itself. Then you have structured note-taking. This is where the AI actively maintains its own external memory, like in a simple text file. There's this one incredible example where an AI playing Pokemon used this to keep track of its progress over thousands of steps in the game. It would write down its goals, what attacks worked, maps of where it had been, giving the agent this persistent memory it could always look back on. It's amazing. And finally, there are sub-agent architectures. This is just like a good project manager. Instead of doing all the tedious research themselves, they delegate specific tasks to their team. You have a main manager agent that gives a complex problem to a specialized worker agent. That worker can go off and do all the deep analysis, but it only reports back a short, condensed summary to the manager. This keeps the manager's context totally clean and focused on the big picture. So the crucial point here, the thing that ties all of these techniques together, is this. Whether it's through compaction or note-taking or delegation, the goal is always to find the smallest, most powerful set of information, the high signal tokens, that will guide the AI toward the right outcome. It is all about efficiency and focus. Look, this all represents a really fundamental shift. We're moving from just telling AIs what to do to actually teaching them how to think, how to focus, and how to learn over these incredibly long periods of time. And it leaves us with a pretty fascinating question to think about. As AIs get better and better at managing their own attention, what truly complex, long-term problems in science and engineering could they finally help us solve?